Hello everyone, welcome back to my channel, Tales of Chemistry. Hope you have enjoyed the previous episodes. Today we are going to discuss the chapter Sulphuric Acid. Sulphuric acid is a standard 10 ICSE chemistry chapter. In this, we are beginning today's session with the industrial method of preparation of sulfuric acid, which is called contact process. Now, here there is one question possible. They may give you the name of the process and ask you what is the purpose of this contact process. Answer has to be the purpose of contact process is to manufacture sulfuric acid, or else you can write to prepare sulfuric acid industrially. Now, if you stop your answer at to prepare sulfuric acid, you will not get that marks for the question. To prepare does not mean industrially. It can even be a lab method of preparation. So complete your answer. Contact process is to prepare sulfuric acid industrially. Now let's see what are the steps involved in contact process. Now, the first step takes place either in the sulfur burner or it takes place in the pyrite burner. Either in the sulfur burner or in the pyrite burner. Let's see what happens in the sulfur burner. S, that is sulfur, burns in oxygen, S plus O2, and this gives us SO2. Sulfur burns in oxygen to give us sulfur dioxide. At the same time, in the pyrite burner, end product is the same, which is sulfur dioxide, but we are starting with iron pyrites. Iron pyrites formula is FeS2. This is iron pyrites, which has to be burnt in oxygen. Definitely, you will get the oxide of iron, which is Fe2O3. Along with that, sulfur dioxide. Now, how to balance this equation? Fe2. Yeah, let's begin with the metal, balancing the metal first. So, you have Fe2. So, if I start with writing a 2 over here, that probably will lead to a problem. See, 3 plus 2, 5 oxygens are there, odd number of oxygen, but I need oxygen in even number. So what I'm doing is just write a 2 over here. So 2 into 3, 6 plus 2, 8 oxygens, okay, which is in even number now. So I come back and write 4 here instead of 2 FeS2. Now I'm writing 4 FeS2, which made the number of sulfur 8. Yeah. So come back and write 8 SO2 here. Now tally the number of oxygen atoms. 6 plus 16. I have 22 atoms of oxygen on the right side. So write 11 O2 here. So we are done with our step number 1. Either burn sulfur in oxygen or air or burn FeS2. FeS2 is called iron pyrites. That's why it is the pyrite burner. Name of the chamber is pyrite burner. Now, ultimate result of step 1 is sulfur dioxide. Collect that sulfur dioxide and subject it to the next step. The next step takes place in contact tower. The second step happens in contact tower. This is a very frequent question, to write the equation that takes place in the contact tower. Let us see what is happening here. SO2, okay, SO2 is treated with oxygen. SO2 treated with oxygen in presence of V2O5, vanadium pentoxide, which is the catalyst, okay, at about 450 to 500 degrees Celsius of temperature and 1 to 2 atmospheres of pressure. All right. And the product obtained is SO3, that is sulfur trioxide. Balancing is simple here, so I'm not explaining that. Now, when the question is to write the equation that is taking place in contact process, you need to write with all conditions. That is, V2O5 is the catalyst. Whether asked in the question or not, you have to mention the conditions. 450 to 500 degrees Celsius of temperature, 1 to 2 atmospheres of pressure, SO2 is converted to SO3. Another point to be noted here is the reversible arrow. Now, you may also find in your book that platinum has also got catalytic properties in this reaction. Platinum can also act like a catalyst in contact process, but we still do not prefer platinum. We do not prefer platinum. Now, when this question is asked, why is platinum not a catalyst for contact process? The immediate response that comes in the mind of a student is platinum is very expensive. Yes, you are right. Platinum metal is very expensive. But that's not our reason to use platinum as the catalyst. Our reason here is platinum loses its activity easily. Metal platinum loses its catalytic properties or activity easily. So in other words, you can also write platinum gets poisoned easily. This is a probable question. Though platinum can act as a catalyst in contact process, why are we not using platinum? Answer: platinum loses its catalytic activity easily. So what is the meaning of this losing its activity easily? See, now if there are any impurities present along with SO2, we are subjecting SO2 to a long, tedious step of purification. But even after that, if there are any impurities remaining, those impurities can attack platinum and thus platinum loses its activity. That is the reason we don't prefer platinum. We use V2O5, which is vanadium pentoxide. Thus, our step 2 is also over. After step 2, what we have prepared is SO3, sulfur trioxide. But what we need is sulphuric acid. Now, step 3 takes place in absorption tower. Step 3 takes place in absorption tower. Now, what is happening in absorption tower? we are collecting that SO3 of step 2 and passing it through concentrated sulfuric acid. Concentrated meaning almost 98% concentrated sulfuric acid is to be taken and then pass SO3 through concentrated sulfuric acid. You get your product H2S2O7. Just see here, I'm adding both the reactants together. Two of them, H2S2O 3 plus 4, 7, H2S2O7, which is called pyrosulfuric acid. Pyrosulfuric acid, or it is also called oleum. Now, one very serious question that arises here is, in some other chapter, acid, bases and salts chapter, we have studied that SO3 plus H2O gives us H2SO4. Now, when this step is existing, when we know SO3 can combine with water to give you sulfuric acid, why are we passing SO3 through concentrated sulfuric acid and preparing pyrosulfuric acid? Why can't we go for this method? Well, we can't go for this method because when plenty of SO3 passed through water, so the problem here is a lot of SO3 is passing through water. You will get dense, thick, white fog of sulfuric acid, which will take a long time to condense. So this can be a give reason question. Why is SO3 not passed through water? Instead, it is absorbed in concentrated sulfuric acid. Okay, so the reason is, if plenty of SO3 is passed through water, plenty of SO3 is passed through water, dense, thick fog of H2SO4 is obtained. Yeah, dense fog of H2SO4 is obtained. Which takes a long time to condense. This takes a long time to condense. So that is our problem here. We cannot pass SO3 through water. Meanwhile, if you're thinking, then why was this told to us earlier? That is because we are expecting you to pass a small amount of SO3. Traces of SO3 when passed through water, definitely you will get sulfuric acid. But here the problem is, it is industrial preparation of sulfuric acid. I hope step 3 is also clear. Moving on to step 4. In step 4, okay, the oleum which you have prepared, in step 4, oleum which you have prepared is diluted with water. That's the reason the last chamber is called dilution tank. The process that takes place here is just dilution. Now, you will have to collect H2S2O7 oleum, treat it with calculated amount of water. Do not add a lot of water. You will get very dilute sulfuric acid as your product. So add calculated amount of soft water. Then H2S2O7 plus water gives you 2 molecules of sulfuric acid. Therefore, the end product of contact process is sulfuric acid. There are altogether 4 steps. At the end of the 4th step, after dilution in water or with water, you are getting sulfuric acid. And then you can concentrate it, whatever is your concentration. If you're actually adding just enough water, you will definitely be getting concentrated sulfuric acid. All right. So we just prepared concentrated sulfuric acid now. Suppose you have to dilute sulfuric acid. You have to dilute that concentrated sulfuric acid. So how to dilute? How do we dilute? How do we dilute concentrated sulfuric acid? Fine. Now, suppose such a question is asked. Now, the meaning of the question is, obviously, we know we will dilute sulfuric acid by adding water, right? Now, the question is, should I add water into concentrated sulfuric acid? Or should I add concentrated sulfuric acid into water? So, actually, concentrated sulfuric acid is added to water, not the other way. You have to take water first and then little by little keep adding concentrated sulfuric acid till the required concentration is attained. What will happen, or why is it required to add sulfuric acid to water? The mixing of concentrated sulfuric acid with water is an exothermic process. So the first problem here was diluting sulfuric acid is an exothermic process. What does that mean? Heat energy is released to the surroundings. Now, if you are adding water into a large quantity of sulfuric acid, what will happen? Lot of heat energy will be released. So, if water is added to concentrated sulfuric acid, what is happening? Lot of heat energy will be released. Yeah, lot of heat is evolved or released. Now, this heat released is sufficient, yeah, to spurt the entire mixture out. This will make the entire mixture of sulfuric acid and water mixture to spurt out. Now, how is that dangerous? See, one person will be working with this, right? So probably, one person took a lot of sulfuric acid and he added a bit of water into it. A lot of heat energy is released and that will make the entire sulfuric acid mixture to come out, and definitely it will, damage that person's skin, right? It will damage that person's body. Right? So we have to be very careful while preparing dilute sulfuric acid. We need to take water initially, then add sulfuric acid little by little with constant stirring. Now, let us continue with the chemical properties of dilute sulfuric acid. Dilute sulfuric acid is a typical dibasic acid. Dibasic acid, word meaning typical. We know it shows all the properties of an acid. It behaves as a, perfect acid. That's all the meaning of typical is. Dibasic acid. Let's find out what is the meaning of dibasic acid. Sulfuric acid dissociates to give H plus and HSO4 minus ions. HSO4 minus is called bisulfate ion. Now, that HSO4 can undergo further dissociation to produce one more H plus and SO4 2 minus. Now, adding these two together, H2SO4 plus HSO4 minus. So I just added the left-hand side components together. Gives me H plus and H plus, 2H plus and HSO4 minus and SO4 2 minus. Now cancel the identical terms. What is remaining? Sulfuric acid dissociates to give 2 H plus ions and 1 SO4 2 minus, that is sulfate ion. This proves us that one molecule of sulfuric acid can dissociate to produce 2 H plus ions, which makes sulfuric acid a dibasic acid. Moving on, we need to learn the reactions of active metals plus sulfuric acid dilute, and this gives us the corresponding salt, which is metal sulfate here. The salt obtained is a sulfate, metal sulfate and hydrogen gas. All right. Now, which metal to be taken? Okay, let me just take Zn, Fe and Mg. Now, each one of this is treated with dilute sulfuric acid. So, displacement reaction takes place. 9th standard, we have studied this. The type of reaction here is displacement reaction. And what you get is ZnSO4 plus H2. ZnSO4 plus H2. Similarly, iron Fe and dilute sulfuric acid gives you FeSO4, ferrous sulfate and hydrogen. The last example, Mg and H2SO4 gives you MgSO4 and hydrogen. All right. There will be a question that how will you conclude that it is hydrogen, or name the gas evolved and suggest a test for the gas. I have already discussed this in HCl part 1. So if you have any doubt, please go and refer that video on HCl part 1. All right. Anyway, hydrogen is a colorless gas which burns with a pale blue flame. That can be written as a test for hydrogen. All right. After this, what we need to study is base. What kind of base? Metallic oxide or hydroxide can react with dilute sulfuric acid to give us salt. Salt here is the corresponding sulfate, salt and water. Let's take some examples for metallic oxides. Sodium oxide, Na2O, sodium oxide. If this is treated with sulphuric acid, yeah, if Na2O is treated with sulphuric acid, you will get Na2SO4, that is the salt, the corresponding sulfate of metal sodium, Na2SO4. Along with this, H2O, water. Another oxide that we can take is MgO. MgO, when treated with sulfuric acid dilute, gives us MgSO4. Metal is Mg, so its sulfate is MgSO4 and water. Now, let me take one or two hydroxides also. NaOH, sodium hydroxide. Sodium hydroxide with sulfuric acid. Yeah, it's compulsory to write dilute. Now, metal is sodium. The sulfate of sodium is Na2SO4. Before I write water, let me write 2NaOH. Na2SO4 is there, so I should write 2NaOH here. Plus water. How many molecules of water? I have H2 and again here 2 hydrogens, right? So I have altogether 4 hydrogens. So let me write 2H2O. Then if we treat zinc hydroxide with dilute sulfuric acid, zinc sulfate will be obtained, ZnSO4 along with water. Balancing, Zn is balanced, sulfate is balanced, but water, hydrogen and oxygens are not balanced. So, let me write 2H2O here. Now, in all these cases, what you're noticing is a base when treated with dilute sulfuric acid gives us salt and water. That is called neutralization reaction. Anyway, what is the base? What are the bases that we are going to consider here? We are considering metallic oxides as well as hydroxides, metallic oxides or hydroxides. Well, now, the next set of reaction is between metal carbonates. The third type is between metal carbonates or bicarbonates. Metal carbonates or bicarbonates with dilute sulfuric acid. Metal carbonates or bicarbonates with dilute sulfuric acid. So, let me take Na2CO3, sodium carbonate. When I treat sodium carbonate with dilute sulfuric acid, corresponding sulfate is Na2SO4 plus the other products are H2O and CO2. H2O and CO2. Never write these two together as H2CO3. Though H2O with carbon dioxide or carbon dioxide passed through water must give us carbonic acid. We are not allowed to write carbonic acid here. Reason, carbonic acid is unstable. Carbon dioxide dissolves in water only under high pressure. So H2CO3 is unstable. You're not allowed to write H2CO3 here. You have to separately write water plus carbon dioxide. Now, another one carbonate that we can take is CuCO3, copper carbonate. Now, when copper carbonate is treated with H2SO4, that is dilute sulfuric acid. Copper carbonate is treated with dilute sulfuric acid. You will be getting CuSO4, copper sulfate, water and carbon dioxide. One or two bicarbonates if we take. NaHCO3, sodium hydrogen carbonate, sodium hydrogen carbonate or sodium bicarbonate plus dilute sulfuric acid. Sodium bicarbonate plus dilute sulfuric acid gives us the salt of sodium with sulfuric acid, Na2SO4. Quickly balance this, 2NaHCO3. Now, 2 molecules of water, because I have 2 plus 2, 4 hydrogens, and 2 molecules of carbon dioxide. Any other bicarbonate you can take, probably KHCO3, potassium bicarbonate or potassium hydrogen carbonate. Treat it with sulfuric acid, dilute. The result will be salt of potassium with sulfuric acid, K2SO4. So I need to write 2KHCO3. K2SO4 plus 2H2O plus 2CO2. Test for carbon dioxide is a possible question, which I have clearly explained in HCl episode, part 1. Please go check that. Time being, let me just tell you, it is a colorless, odorless gas which turns lime water milky. Colorless, odorless gas which turns lime water milky. Now, the next reaction is, fourth one is metal sulfides. Metal sulfides react with dilute sulfuric acid. Metal sulfides react with dilute sulfuric acid to give us salt, water, and sulfur dioxide. Salt, water, and sulfur dioxide. Now, in this, let me take Na2SO3 as the sulfite. Na2SO3. This is treated with H2SO4 dilute, gives you the sulfate, which is Na2SO4, sodium sulfate, water, and sulfur dioxide. Let me take one more sulfite, MgSO3, magnesium sulfite. If you treat this with sulfuric acid, what you get will be MgSO4, magnesium sulfate, plus water, magnesium sulfate plus water and sulfur dioxide. Okay, test for sulfur dioxide is colorless, choking odored, or colorless, irritating or burning sulfur smelling gas SO2 is obtained, which turns lime water milky. Both carbon dioxide and sulfur dioxide turn lime water milky. Difference is carbon dioxide has no smell, but sulfur dioxide has a burning sulfur smell, or kind of a choking, not so pleasant smell. The last set of reaction that we need to study here is metal sulfide. Metal sulfide. Ide means there is no oxygen. Metal sulfide and dilute sulfuric acid gives you the corresponding salt and hydrogen sulfide gas. The moment we hear this word, H2S word, we must remember that it has a rotten egg smelling. It is a rotten egg smelling gas. Well, let me take some examples for metal sulfides. Sodium sulfide, if treated with dilute sulfuric acid. Sodium sulfide, if treated with dilute sulfuric acid, we will be getting Na2SO4 plus H2S. Now, ZnS, if treated with sulfuric acid, dilute sulfuric acid, gives us ZnSO4 plus H2S. So any sulfide when treated with, so at the end I've taken FeS, when treated with dilute sulfuric acid, it gives us FeSO4 along with H2S. Yeah, H2S is a rotten egg smelling gas, and the test for H2S is it turns moist lead acetate paper black. So that's all in this episode. Stay tuned for more videos. Thank you.